Hi, my name is Laura, and I am here to introduce you to engineering. Now I know, some of you might already know a little bit about engineering, but when I was in 8th grade, I thought an engineer was the person who drove the train and pulled the cord for the whistle. Toot, toot. I didn't have a clue about engineering, but by the end of 8th grade, I knew that I was going to be an engineer. Now let me guess. You're probably sitting down watching this on a laptop, or maybe a smartphone or a tablet. And you probably have shoes, even if you haven't worn them for a while because of COVID. And you've probably been in a car. Now, all these things, as you can guess, exist because of engineering. And really, engineering is all around us. And despite the fact that it's literally on us, it's hard sometimes for us to really know what engineers do. And so today I'm going to tell you a little bit about what engineers do and how you can be an engineer. But what I want you to take away today is this. Engineers have a heart for helping society. And if you find your passion, what makes you tick, and you work hard, you too can be an engineer and leave your mark on the world. So let's go back for just a moment to when I was in 8th grade. Now, my dad had taken me to see a movie called October Sky, which was set in Colwood, West Virginia, where there were, most of the adults ended up being coal miners. But there was a small group of students, and they wanted something different. And they were inspired by the space race of the 1950s. They wanted to do rocketry, but they had really limited resources. But that didn't hold them back. In fact, they ended up winning the National Science Fair for rocketry, and one of those students became an engineer for NASA. You see, like these students, I also didn't have much help with my math and science homework after 8th grade. In fact, I wasn't even good in math and science. But I knew engineering was in my future because I wanted to make a difference, and I felt like that was the right way to do it. So what I'm going to talk to you about today is how engineers play a role in making our world better. And I'm going to show how you too can be an engineer and leave your own long-lasting mark on society. So let's begin. As I mentioned, engineering really just happens all around us. From your chair to your pen to the roads we drive on and the air we breathe, both indoors and out. Engineering is with us. Now, here's some examples. Who posts on social media? Yeah, computer engineering paved the way for that. What about music? Do you like to listen to music? I figured so much. Yes, well, that is also here because of electrical engineering. And do you wear deodorant? Or maybe some of you wear makeup. Well, those are produced on manufacturing and production lines, which are here because, again, of, you got it, engineering. And as we engineers develop the next generation of ideas and products and projects, we have to be sure we do so safely and that we don't harm the environment. And when I think about that, not harming the environment, I think about sustainability. And what that means to me and the company I work for is protect tomorrow, today. Engineers are at the core of our ability to protect tomorrow, today. Think about it. How do we design products for reusability and recyclability? How do we begin with the end in mind and conserve natural resources? Well, here are some great examples for you. Think about mechanical engineering. So mechanical engineers can design products for reusability. What comes to mind is a reusable water bottle. Industrial engineers integrate systems and processes for efficiency, which is fancy engineering lingo to say that they make things work less hard but produce just as much with less energy. We also have chemical engineers, which are a lot like industrial engineers, but they incorporate chemistry and biology into their processes. And then materials engineering. Materials engineers use products and find ways to improve products through lightweighting and durability. And they also design products for recyclability and ensure that they last as long as we need them. And then we have cars, automotive engineers, computer engineers, electrical engineers, and aerospace engineers come together to build cars that are faster, more reliable, and require less fuel to operate. Now let's think about the communities we live in our own backyards. And I'm talking about transportation and housing and population density, how many people live and work in one area, and clean air and water and public spaces. So have any of you ever been on a train or in a subway or on a metro line? Well, civil engineers and computer engineers and electrical engineers come together to build new public transit systems that reduce the amount of land that we need to transit a lot of people, thus reducing traffic. And what's great about that is that can enable more people to live in one area. So architectural engineers and civil engineers design big buildings like apartments, condos, and high-rises, which can house more people. They also design shopping centers to meet our needs while respecting natural resources. This allows community planners to plan and allocate for more green space, like parks and trails, so we can enjoy more time in nature. And another part that's really important is the clean air that we breathe, and water and sanitation. Now, when I talk about sanitation, I'm talking about keeping dirty water and clean water separate, so that you can treat the dirty water and then put that back into our ecosystems, into the rivers and lakes where they sometimes come from. And that's important for environmental engineers. So now, as you can hopefully piece together, engineers are well integrated into our efforts to protect tomorrow today. In fact, without engineering, the world that we know today really wouldn't exist. Can you think how bad traffic would be? I mean, you wouldn't be able to look forward to that cool next piece of technology. And even things we take for granted, like clean air and water, would be a little more difficult for us to enjoy. Do you remember what I said just a moment ago, that engineers have a heart for helping society? Well, many of us have a passion for doing so. And if you can find your passion, what makes you get excited, you too can be an engineer and leave your long-term mark on society. There are so many challenges that need to be solved, whether it's an environmental challenge, a transportation or a housing challenge, or new technology and innovation. There will always be a need for human ingenuity. And you can start today. In fact, I want you to start today. First off, recognize that even if you aren't good in math and science, you can be a problem solver. Go all in as you learn about engineering. Don't hold yourself back, and do not limit your abilities. And finally, go and ask yourself, what inspires me to protect tomorrow today? Maybe it's designing a new reusable product. Maybe it's championing efficiency or transportation. Maybe you like new technology, or you want to take complicated problems and break them down into simple ones. Connect what you learn about engineering to what gets you excited and pumped up. And good luck. I hope to see you in 10 years changing the world.
Hi everyone, I'm Tiffany, a 10th grader from Texas. Laura, thanks for talking to us about engineering and for sharing all the cool things an engineer gets to do. I learned so much and I'm so excited for the next part of our program. We are going to hear from 3 ExxonMobil engineers about what they do, how they got to where they are today, and lessons they've learned through engineering. Let's meet these engineers. When I introduce you, will you share what type of engineer you are, your title at ExxonMobil, and the number of years in the industry? First, we have Silvana Azana.
Hi, Tiffany, and hello to all the students watching us today. I'm a civil engineer from school, but I'm currently a commercial advisor for our acquisition, sales, and trades group within ExxonMobil, and I've been with the company for 6 years.
Thanks, Silvana. Next, we have Sam Bari.
Good morning, Tiffany. I studied mechanical engineering in school and now work as a wells engineer doing drilling engineering. I'm in my 2nd year with the company.
Last but not least, we have Erika Anderson.
Hey everyone, I'm Erika Anderson. I am a mechanical engineer by training, but here at ExxonMobil, I'm a reliability engineer, and I've been with the company for 6 years.
It's very nice to meet you all. So let's kick off this panel. My first question is, what does your daily life look like as an engineer? Erika, will you start?
Absolutely, that's a great question. So I want to start this by saying, for one of the things I love about being an engineer is my job is always different. My job title is the same. However, I'm always working on different types of projects. So I'll tell you a little bit about what I'm working on now, but just know if you were to ask me the same question like a month from now, my answer would be different, as I'm always moving from different projects, working with different sites. So, but daily, it always starts off with, I need my coffee. I get my coffee and start checking emails in the morning. So from the time I left the day before to when I get back in the morning, it's insane the number of emails that I would have gotten by then. So from checking emails, I kind of make a work list. I pull out my planner and make a work list of what I'm going to try to knock out that day. And so currently the biggest project that's on my plate, and it's one that I really enjoy, is making an equipment strategy. So I'll compare this kind of to your parents' car. So if you know that your parents' car, it has different maintenance intervals. So like every 3,000 miles, you've got to go get your oil changed, you get your oil filter changed. You know, these are all these different types of maintenance that you do on the car to keep the car running. Well, there's some manual that engineers came up with to determine how long is this oil going to last? How long will your engine last? How long will the filter last? To tell you that, hey, you're getting to the end, you need to go change this out before your car shuts down on you. So an equipment strategy that we use for our refineries, our chemical plants, are exactly like that car manual. And we as engineers, we all come together and we look at the different equipment. So in a refinery, I don't know if you've driven by one before, but you see all the piping, you see these giant towers, their reactors, you see pumps, compressors. Each one of those pieces of equipment, we have a strategy on. And so we get engineers together in a room. I'll lead that session, but I don't know a lot about the process fluid. You know, it's going through some piece of equipment, but I'm not a chemical engineer. So I don't know the molecular structure. I don't know how it's going to damage the equipment. So I've got a chemical engineer on my team that I get to work with, and they can tell me that. I also don't know, well, when it starts to get damaged, someone's got to inspect it. So I got inspectors on my team and they can tell me that much. Well, when that happens, we got to repair it. I don't necessarily know how the repair goes, but my maintenance engineer does. So one of the cool things about building these equipment strategies is we're pulling together a bunch of different engineers in one team. And I don't have to be the know-it-all. I just ask the right questions to be sure that we're identifying, hey, when's the end of life for this piece of equipment? When are we going to need to go in and inspect this or go in and replace to make sure that the equipment still runs reliably? And so right now, that's the biggest thing on my plate. And since I'm working with a new site, Baton Rouge, I've never worked with them before, there's a lot of learning involved. I've got to learn how their site runs. I don't know it. I work here in Houston. So that's something I really love about my job is one, it's not always the same. And two, I'm always learning something new and relying on other people to learn something new.
That's so neat how you work so well in a team. I'm sure you learn so much every single day. Sam,
Absolutely.
Ooh, so a little context for mine is that I work as a rotator and split time half and half between my home in the US and my assigned location. My team and project is the Guyana Wells team, which oversees all the upstream work in Guyana, a country down on the northeast edge of South America. Within that team, I'm a drilling engineer for the Stena Karen, which is a drill ship that performs exploration and appraisal work, doing drilling and well test activities. Every day that I'm down there, I spend at work is different because of the broad scope of the work that we perform. I truly think I have the coolest job in the world because of the scale and the complexity of the projects and our ability to see the direct impact of the design work we do as it gets executed. Kind of mirroring what Erika said a moment ago, we coordinate so many different personnel. The job feels pretty social and active. I'm always collaborating with other team members, and I seldom, if ever, find myself glued to the desk for more than a few hours at a time.
I didn't know that was all a part of engineering. How interesting. Silvana, what does your daily life look like?
No 2 days are the same. Things are always changing in our projects, and so we have to be very fluid and be able to adapt to that change. But most of the time, working a lot with teams, data gathering, of course, reviewing emails and meeting with other folks on our project.
Thanks, Silvana, and thank you all for sharing. I had some ideas of what the day-to-day life of an engineer could look like, but now I understand it so much better. Even though you're all engineers, as you all mentioned, your days don't look the same. I love that. Well, as a 10th grader, I'm clearly not about to embark on my career, but I do have goals and dreams about what I want to do when I graduate college. Can you all tell me what steps you took to get to where you are today? I know that information will be helpful for me, and I'm sure it will be helpful for the other students watching. Sam, do you want to go first?
Sure. So back when I was in 10th grade, and as I got later into high school, my high school gave us the opportunity to sneak in a couple electives. And I used it to get some science and math and basically get the broadest education base that I could get. We also had a fun chem club, which was a little bit of study of chemistry, but more so doing fun labs and making things go boom. So getting involved in that. And then later, as I worked into college, it was again, having the biggest, broadest educational base I could have.
That's so interesting, Sam. I'm definitely taking notes. Silvana, your turn.
I have to say, the summer right between junior and senior year of high school, I was fortunate to be able to do an internship in civil engineering. And that was like the life-changing moment for me. I knew I was interested in engineering. I wasn't sure really which one. I even considered architecture at one point, but that civil engineering internship was the one that helped me confirm that I wanted to study civil engineering in college. And so what I actually, as part of that internship, they took us to job sites where I had a chance to see heavy equipment moving around, freshly poured concrete being set. And honestly, I was just mesmerized and loved the fun and thought it all looked so interesting and so cool that I was like, okay, this is it for me. And then once I went into college, I actually did more internships that helped me understand more about which path I wanted to take in civil engineering, because there's so many different paths. So I think, long story short, what I would say is doing an internship in the potential career that you want to explore is one of the best ways to go. It'll help you see if it's maybe what you really want to do, or perhaps you may want to try something different afterwards. So internships are really the way to go.
Thanks, Silvana. Okay, Erika, what about you?
So my answer is actually going to sound pretty similar to what you just heard, because I totally agree with them. So I've always loved math and science, but I didn't learn what an engineer was until my senior year in high school. Up until then, I thought an engineer was a train driver. No one actually told me, but I did get the chance to do a summer program between my junior and senior year while I was still in high school at the University of Michigan. So that's one of the things I'd recommend, that is try looking up different programs for high school students. Because when I was there, that's when I first got introduced at least to more math, more physics, and I fell in love with math. So I actually have 2 degrees. My first degree was in math, and I love engineering because I love math. It's an application of math. And so by the time I got to my senior year, I really didn't know what I wanted to do. So I just Googled majors for people who like math and science. And I think if you still do that today, the first one is engineering. And I read it and I really liked what it sounded like. I mean, it said people who like math and science, lifelong learner. And I think this is the career path for me. So once I got to college, that was my major. And something you've heard from my colleagues here is getting experience. So I think one of the most important things for me, because I was still new to the idea of engineering, was trying to find internships, because I really didn't know, it's so many of them: chemical engineer, aerospace engineer, biomedical engineer, mechanical engineer. It's like, I didn't know what I wanted to do. So at one point I called myself biomedical. And then I ended up getting an internship with NASA after my freshman year. So I thought, ooh, maybe I'll be aerospace. Well, turns out I actually didn't like NASA that much. And that's when I decided to kind of switch gears. And I ended up interning with GE Aviation. And I worked with a lot of mechanical engineers, and they're telling me like, hey, well, maybe you can get a master's later on in aerospace, but mechanical is broad enough for you to, get your hands in a lot of different things. And so that's how I ended up sticking with mechanical. And I ultimately ended up getting an internship here at ExxonMobil. And by the time I was over, they liked me enough to offer me a full-time job. So I'd say that internship experience, it'll teach you what you like just as much as what you don't like. And if a company likes you enough, if you perform, you can end up getting your full-time job.
Thank you, Erika. The 3 of you are helping me see that it's never too early to think about your career and your goals. Even though I'm just in high school, I can still make decisions now and be involved in things that will help me be successful later. All right, time for our next question. I want to know what challenges you have faced since becoming an engineer. Your work is difficult, I'm sure, so I bet the journey hasn't always been easy. Will you tell me about those challenges? Let's start with you, Silvana.
I really like that question, Tiffany, because I got to share with everyone, I personally struggled with some of my classes in college, especially calculus and all of those math-based courses. I know Erika said, right, math was her favorite, and it really was mine too, but it never came really easy. And I knew I had to put in extra work, extra effort to be able to get really good grades and understand all the math concepts. And of course, all of those translated into more engineering courses. So I got to say, there were definitely some tough late night studying. I think that was probably my biggest challenge when studying for all of my engineering classes. But now that I look back, I think to myself that it was also worth it. And I honestly love being an engineer, and I'm just glad that I didn't let the difficult aspects of the challenging courses in engineering, let that from stopping me. So honestly, I know there are students out there who struggle probably with the same, struggle with math or maybe other subjects like science, but don't let that stop you really. If you want to pursue engineering, go for it. Because I was in your shoes, and if I was able to do it, I think anyone else can.
Thanks for sharing that. I'm sure facing those roadblocks was difficult, but it's so cool how you learned and grew from them. Erika, let's hear from you next.
Another challenge that I face, which I kind of didn't see coming, is engineering is a male-dominated field. You know, we kind of know that. It's kind of assumed like guys will be better at it than us girls. So sometimes it can be challenging when you're the only woman. You know, you're in a room and you're the only woman, and so it can get intimidating sometimes. And I kind of got to pump myself up and remind myself, like, oh, girl, you got this. You're a great engineer. You know this stuff. And just to have that same confidence and bring that to the room. So it was a challenge I didn't see coming, but I've gotten so much better at dealing with it now that I'm 6 years into my career.
Thanks, Erika. I bet you learned a lot from those challenges too.
Absolutely.
Sam, do you have a similar experience? Will you share with us?
Yes, and I'll answer it kind of in two parts like Erika did a second ago. As a student, the courses are challenging, but you have the resources, you have older students, you have access to professors and stuff to get through it. And I think the challenge is kind of what makes it so much fun, because it's the pride once you actually achieve and finish through it. I also think now in career, that's another fun part of the job. You come in and there's so many acronyms, slang terms, this, that, whatever else, that you don't know where to look, where to go to. But we're really fortunate to have more experienced employees. And we have a group that's our technical team. They're subject matter experts. And when I don't know what to do, I call up my best friend at the office, who is a man much older than myself, and say, sir, where do I look for this? I call our technical expert another and say, ma'am, I need a little help. And it's really, really rewarding that I have these older personnel that are so willing and engaging to help all of us. So my roadblock is my lack of experience, but what I'm thankful for is that there are those that are willing to lend their experience to me and help me out.
That's so interesting. Resources are definitely important. All I can say is that I'm impressed by all of you. To overcome all that you did to get to where you are today is such a cool thing. You're definitely role models. Okay, what do you think are the most necessary qualities for an engineer to be successful? I have some ideas, but I want to hear from you all, the engineers. Sam, you can kick us off.
So an engineer is a problem solver. And no matter what field you're in, there is a problem to be solved. So just being adaptable, innovative, and able to apply all your education, all your life experiences to be best suited to solve the problem, to find a way best suited to solve the problem. So above all else, I'd say just being adaptable, responsive are the best qualities you can have. Know that everything's always going to change, but there will be a problem to solve for engineers now, in the future, and 1,000 years from now.
Definitely, adaptability is very important. Erika, will you share your thoughts?
Sure. So I definitely think having a love for learning, a joy for learning. So I mentioned earlier, like the project that I'm working on, a lot of it is new to me. And so I'm cracking open some of my old school books. I'm cracking open books that we have here. I'm tapping on some of our technical experts to help me learn about this unit, because I really don't know about it, but that's something that I enjoy doing. So even when you leave college, the learning doesn't stop. You're constantly learning something new. There could be new regulations that come out. And so what we did before is no longer okay. So you've got to learn the new way to do things. There are new work processes. But to me, that's what keeps it fresh. It keeps it exciting to where you're not doing the same thing over and over again. So even if there's some things that I learned that I'm really not a fan of, but I got to know them as part of my career. And then once I learn them, it may be challenging, but I feel good after the fact. It's like, yeah, I did that. Like I surmounted that. So.
Yeah, continuous learning is super cool. Silvana, what about you?
I'd have to say two things: being curious and being adventurous. Like Sam said, engineering is all about being a problem solver. So if you're curious and you have that inquisitive mindset, you're going to look and search for answers and solutions. And that's really what engineers do, right? We're problem solvers, looking for answers, looking for solutions. And then the second component, being adventurous, I think is key, because if you're adventurous, then you're courageous. So you won't give up. You won't let roadblocks or challenges kind of get in your way and say, maybe this experiment's not going to work out. I'm done here. No, I think if you're adventurous and you're courageous, you'll have the courage of conviction to really continue searching for a solution, searching for an answer. And honestly, we need the young engineers, the young aspiring engineers, like the students that we're probably talking to today, to come out and help us solve those challenges that we're going to have in the future. They're not going to be the same challenges that we have now, but if you're adventurous and if you're curious and you're determined, I'm certain that they will be able to help us find some of those answers.
Thanks, Silvana. Each of you listed some very necessary qualities of engineers, and I will definitely be thinking about those when I think about what engineers are like today. My next question is, what are some of the biggest life lessons you've learned through engineering? Erika, will you go first?
Sure. So the one thing that immediately comes to mind for me as my biggest life lesson is that losses or even mistakes are lessons themselves. It's easy to feel defeated by them, even in college. Maybe you got a bad grade. It's easy to feel defeated, but you learn from it. You learn from those mistakes. And then the same thing in my career. Early on, and even still now, I've made mistakes. I've made wrong calculations. I've made wrong decisions, but I learned from them. Just like my internship. I chose NASA. Didn't really love it, but I learned that I didn't like it and I learned something else I can do. So I would definitely say losses are lessons and always learn from them. Thanks,
Erika. Sam, what about you?
I think Erika kind of stole mine there, but it's such a good point that I'll let her take that one. I'll go kind of a similar route there. Learning what you don't enjoy and what your weaknesses are. It's just as important as learning what you do enjoy and what your strengths are. I had an internship that was between my freshman and sophomore year of college that taught me that I didn't necessarily like the construction industry, but it was just a stepping stone to finding where I was going to end up and do enjoy. And the other thing I'd say is that you need to take it slow and don't rush. Developing an engineering skill set and expertise in any field doesn't come overnight, and you can't study for 3 days straight and work your way into it. It's a slow progression. And it's a lifelong progression. None of us will get there in a year or two. It's something to work for long term.
That makes so much sense, Sam. Silvana, will you share your thoughts?
I think Erika and Sam have already nailed it there. But what I would add to that, I think one life lesson that I've had from engineering is learning to not just be bogged down with the challenges, right? We hit roadblocks. Classes were challenging. Once you start your career, things get challenging too at work and in your projects, schedules to meet, budgets to adhere to. Lots of different aspects make an engineering career challenging. But instead of being focused on the challenge, think about the opportunities instead, right? And almost tackle it as an opportunity and not necessarily a challenge so that you can have a better outcome in the end. I think if we kind of just switch our mindset that way and instead of seeing the challenges, seeing the opportunities, that's when more doors open, more solutions come to the table and teams are able to work so much better together. So I could apply that to so many things. And I want to say I'm probably more on the optimistic side of things, but I like to take that perspective for all of my projects and when I work with my team.
Thanks, Silvana. I've learned so much from each of you. Silvana, Erika, Sam, thanks for spending time with us today on this amazing panel. I learned so much about engineering, the different paths you can take to become an engineer, and what successful engineers are like. It's so helpful to know that we're all likely to face challenges, but there are ways to overcome them and grow from them to eventually have an exciting career. I definitely will be coming back to these notes in the future as I work towards my goals. It was so fun meeting you three. Now it's time for an exciting experiment. Let's go learn how to build a straw tower with our three panelists.
So thank you, Tiffany, for that great panel discussion. I'm Erika, and I'm joined by my colleagues, Savannah and Sam. And today, we're going to be doing a hashtag straw tower challenge. So as of this moment, everyone in the room right now, we're all engineers, specifically civil engineers. They're the ones who are known for building different buildings, towers. Now, when I think of a tower, I think of something like the Eiffel Tower. It's triangle shaped at the bottom, goes up to a peak, something like that. Can you You guys think of a tower?
Freedom Tower. I'm from New York, so I have to say the Freedom Tower.
Okay, New York, I see you. Sam, yeah.
Some cell phone towers that I passed on my drive here today.
Facts, facts. So you think about these different buildings, these towers, different shape structures, but they all undergo different types of loads. And so one of the things that we're going to be thinking about today is we build our tower, as it gets taller, it's going to get wobbly. So as engineers, these are the things that we have to consider when we do design. So as part of our hashtag Straw Tower Challenge, you should already have your supplies. We've got 20 straws, 2 feet of tape, and some scissors. So be careful with your scissors, please. We don't want anyone getting injured. So what we're doing here is we're going to try to build the tallest tower that we can. However, we've got some constraints. All engineers have constraints, whether it's your budget, whether it's time. In our case, you've got limited supplies. You've only got 20 straws, so you got to be careful with them. Also, we've got limited time. So you got to think and plan and execute. Lastly, your tower has to be freestanding. So you can't tape it to the table, guys. That's cheating, engineers. That's cheating. So this is what we're going to be doing. This is my competition, because in my mind, I like to win. And this is a challenge. Hashtag Straw Tower Challenge. So, and I believe all of you in the room can most likely beat us engineers, because we're all engineers here. So with that being said, let's go ahead and get started. Let's build these towers. Okay. So in my mind, I'm thinking I'm going to try something with like a square base and see if I can build it up really, really tall. But I'm not going to lie to you, I'm really concerned whether or not that's going to work out. Okay. Kind of a tool of the trade, kind of trick, if you will, to kind of preserve your tape. You notice if you fold your straw bit in half, you can insert it into the other straw. Got a good little connection there, you push it deeper, it's pretty stable. So you can use that to connect the different members as you build your tower, and it'll help you save some tape.
And it helps make those joints strong, right?
Right, we're definitely gonna reinforce them.
Overlapping the straws.
I'm copying that, starting that.
Okay. Also, I think my straws may be a little too long, so I'm not gonna lie, I'm a little hesitant to cut them because I only have 20 straws, and if I cut it into a shape that doesn't work out, I'm not sure.
Gotta be supply conscious.
Supply conscious, truly. Okay. And you'll notice you may make mistakes. That's part of the engineering design process. You find out what your constraints are, you come up with an idea for a design, and then you try to execute. But if it doesn't work, that's okay. Start over. You repeat the process until we get the end product that we want.
That's what engineers do, right? We're problem solvers.
Always, always.
The material constraint I'm stuck on the whole time is the bigger the base I build, the shorter it's going to be able to go. So the trade-off of stability here is going to become an issue quick.
Yes.
Facts. Thank you for the insight.
Mine might be toppling over here soon.
I think we're, okay, now.
It's probably a good thing those cell phone towers aren't made out of straw.
Thank you. How unsafe would that be, right? Okay. So my idea for a square base, I don't have enough members. I didn't plan this out well, so kind of back to the drawing boards. It may be better for me to do a triangle.
I'm going a little rogue here. I'm cutting my straw. Ooh. I know.
Bold move.
I know.
Bold move.
It is a bold move. We'll see.
And what I thought was going to be a square is turning out to look more like a pentagon. So,
How many in a row do y'all think we can put together before it becomes unstable?
I'm thinking three. My thought was 3.
All right.
Come on, Erika, you're better than this.
Collaborative competition.
Right. That's the other thing. As engineers, honestly, you're always working on a team.
Yes.
And it's always with different engineers. So being able to work with team members, being able to work with your colleagues, you're going to have to be able to do it.
I think almost all of our projects have big teams, and we're always relying on each other, helping each other out.
Definitely. I know that's how it is in my group.
There's always that misconception that engineers work all alone, maybe in a lab, but
Right.
that's really not true.
Right. You definitely need the team. You're literally only as strong as your weakest link on said team. Mm-hmm. Okay. Eureka. Okay. This is something like a square. Something like a square. Okay. I'll try to build up from here. I've already deformed some of my members, so it's another thing.
Yeah,
Let's
this.
Okay. So I try to use my tape at the joints. I think that's my most strategic use of it. But I am still concerned that I might run out. However, as I look to my left and my right, I'm happy that my colleagues look like they're on the same page as me.
I'm getting somewhere. I don't know where, but we're going in a direction here. I've got lots of squares.
So I'm going to be contrarian here. I'm going triangle based.
Triangles.
I'm actually regretting my square base, and we're thinking about some design changes. And as the lead engineer on my project, I can do that. So we might make a little change here.
Own it. You gotta own it.
All right, we're gonna make a cut. First cut of the day. That was nerve-wracking.
All right. Let's see.
You're not an even one. I want you.
Now I gotta figure out a way to connect my two squares. I have two squares. It's not really looking like a tower right
That's
now.
what I'm about to be stuck to as well.
Let's see.
Oh, you're onto something, Sam.
There's going to be a weird butt joint in all three of these corners where it's just up against the side.
I'm glad we don't have to fight wind loading here like with a real building, because my structure would be in trouble.
I think I made a little mistake. I intended to make this fit, but looks like I need it longer. So, whoops.
Your square looks so much better than mine.
Why, thank you. I actually used the bend of the straws too.
And that's where I messed up. So, go with the natural design that you have. Take advantage of the fact that your straw can bend. That clearly is a design advantage that she was able to figure out.
Let's see.
Top of mine's going to have some flex in it.
Creativity. I love it.
We're gonna go 4 deep on the length here. See what happens.
Oh man, this daredevil over here. I gotta get my weight up. I can't lose.
Now, Erika, what's the tallest straw tower you've made so far?
3.5 feet.
Wow.
But, yeah, I'll be honest though, when I've done this before with students, I've never won. So I talked a lot in the beginning, but students are brilliant. Young scholars are brilliant. You all are way more innovative than us old people. So
we're copycats using existing towers over here instead of creating a new one.
Exactly. This is why we need young minds, young engineers, because you all come in with some great ideas.
So everyone watching, they're probably already way ahead of us.
I know. It's probably for the best that I can't see you all, because I imagine you're smoking us all and we're behind here. That's okay though. I got this. We're still gonna win, even though my straw is already falling over. The word of the day is stability. Stability.
And this is a lot of what happens when civil engineers are actually designing not straw towers, but towers. They're trying to understand like how to make the strong base, where the weakest joints are that need additional reinforcing.
Just a iterative process of design, test, rinse, repeat.
Yep.
But it's so
Love the
satisfying
shampoo.
when you get it right though. I mean, you may have a lot of failures along the way, but when you stick with it, that perseverance and those new ideas, take every failure that you did wrong and think, how can I fix that? What can I do to improve that? So right now I'm thinking, man, I should have done a better base for my square. Mine is really lopsided. It's not looking good right now. Let's just hope the mechanical integrity is better than the aesthetics, because this is ugly.
I'm having a materials issue. I think I've used about a foot of my 2-foot tape, and I don't know how much more I got. So we'll see.
Having some doubts on my initial design plan over here, but we're in too deep.
I kind of got to commit. But I'm looking at a solid, maybe 4 inches here. It's better than nothing.
I think mine's a little lopsided too.
It's so stable though, like the way I guess you're going for the triangle, kind of like a truss structure to reinforce it.
Yeah. Here we go. I've got a cube so far. How tall do you
man.
think that is?
Now that is a good looking tower.
Thank you.
It almost looks like an office building. I'd be willing to work there. It looks stable enough. Much more stable than what's going on over here.
Absolutely.
Oh man.
Uh-oh. I don't know if I'm budgeted for more materials or not, but
I did not. And something I'm realizing, I wanted my base to be square and to come up, but when I cut these members, they're too short. They're not meeting in the middle like I wanted them to. So I could use a bunch of tape. Right, there's a design flaw here. Clearly my drawings were wrong, it wasn't me. But it's okay. Let's see how we can fix this. Can I bring these together?
back to the drawing board. We
You
do
know?
that so much.
We do. We probably spend more time at the drawing board than anything else.
But hey, the more time you spend at the drawing board thinking out your design and actually planning out the process, looking at how much materials, I think the better off you might be.
Absolutely.
It's time well spent.
Exactly.
Absolutely. And when you've got a budget and managers wanting you to stay within said budget, you will plan accordingly.
How are we doing on schedule?
We're still on schedule.
We're
We
still
are
on
getting
schedule.
low on time here. So recall we said at the beginning, time was one of our constraints. We only had 10 minutes. And the bosses are looking down on us like, what are you doing? Where's my tower?
no.
Where's my tower? So, oh my goodness, Sam is over here killing. Okay.
Sam, I'm borrowing the triangle concept a little bit here.
Get after
Do you
it.
see this?
Oh, wow.
Do you see this?
What?
It won't stand though.
Yes. There's hope.
There's hope.
Not that I don't want it to stand. Trust me, I'm wishing the best for you, Sam. I am.
So we're team efforts over here.
Right.
And this is where my tape is. So
You got lots of tape.
that's a lot.
Yeah, look at mine. This is all I got.
Ooh, okay, yeah, I do have a lot of tape.
I got a
by comparison.
materials issue here. Let's see.
So at this point,
Fun
At
fact on
time-
the Freedom Tower. Did you know it's 1,776 feet tall? And that's the year the Declaration of Independence was signed.
That is a fun
Hence
fact.
Freedom Tower.
And where is the Freedom Tower?
Lower Manhattan,
All right.
New York. Mine's looking a little
this up.
lopsided, but I think it's holding.
and we're down to the wire, 3 minutes.
Oh
Oh
no.
man.
I think I need to add more reinforcements here. I don't know if it's gonna hold.
Where you at, Sam?
Ooh,
Wow.
there you go.
That's looking good.
But can it take
This
more?
is it, guys. My last 2 pieces of tape. I really got to use these wisely.
Okay, yeah, you were right, Sam. Only 3 in a row.
Yeah, that's kind of the limit.
So it did stack
I
too
went
much.
4 and it's risky business over here. I think it's gonna.
Well, so as you can see, this is definitely a challenge. Hopefully, you tried it and maybe you weren't able to get far. That's okay. The beauty of it, like we said, the engineering design process, it's iterative, it's cyclic. That means that from this point, I could go back and redesign. I could go back and fix my base and make it a triangle and then try to build it up a little taller. Or maybe I do several layers of triangles before I went up to a point. That's the whole point of engineers. We solve problems. And honestly, as you can see from us, we love to do it. And I hope that you as young scholars, that you'll take the same innovation, take that curiosity, take it and use it. You all can be engineers. You all have it inside of you. I guarantee it.
That's so true. There's an engineer inside all of us.
Absolutely. Look at that. Beautiful. It's not as tall as I wanted. Oh,
I know. Jeez, man.
okay. Okay. Okay, Sam.
I know.
Making it happen over
Okay.
here.
Lead engineer. Somebody get this man a trophy. I'm impressed.
One little tough to win though. You blow too hard and this thing's
I
coming
know.
with it.
I hope you all have something taller than Sam's.
The AC unit turns on and it's game over in here.
I was able to use most of my materials, I want to say. Oh no.
I made
probably
good use
should
of
have.
everything, but I've got a bunch of tape left behind.
I do too. The fact that I have so much tape, I think I was a little too frugal with my materials and my supplies.
I ran out of tape completely. Maybe we could have traded.
Could have swapped
right.
some around.
Some bartering.
Train a beam for some tape.
Wow. Okay, well, mine didn't necessarily go as planned, but as we can see amongst us, Sam is our trophy winner here. That is an amazing tower. That would make the Eiffel Tower jealous. So hopefully you all have built something, and I really hope even more as young engineers that it's taller than his. But even if it's not, that's okay. You can still improve on your design. That's what we do as engineers. It's a design process. Look at what you did, see what you can do better, and then try to make those improvements. And as engineers, that's what we're doing. We're problem solvers.
It's true. I think all of us have an engineer within us, and we really need the youth, you guys, for tomorrow to help us tackle all of the challenges that are going to be coming our way. You guys can help us really be those engineers to solve those problems.
Right.
I hope today's exercise helped to show that truly anyone can be an engineer. It starts now.
Absolutely. And we'd love to see your designs. So please, hashtag Straw Tower Challenge. Let us see them. I want to know what you young scholars came up with.